Hey, this is 11.2 from March 24th. On the first one, it says if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So if a line is tangent, so starting with the line being tangent, this one has the line starting being tangent, then it is perpendicular to the radius. So then it is perpendicular second, then it's perpendicular second. So that means the first one is B. The next one, in a plane, if a line is perpendicular to a radius, so starting off with if a line is perpendicular, so right here we have a line that's perpendicular, then the line is tangent, so then the line is tangent, so then the line is tangent right there at the end. That means this one has to be C. Next one, if two segments from the same point outside a circle are tangent, so this one's talking about two lines that are both tangent to the circle. That means that has to be A. Next section. In the diagram below, line AB is tangent to circle C at point B. So line AB is a tangent line. It says name a right angle. So your right angle would be right here. You can call that angle B, or you can call it angle ABC, or you could call it angle CBA. Any of those names are talking about that same angle right there. Number 5. It says AB is perpendicular to CB, so they tell you this is perpendicular right here. It says name a line that is tangent to circle C. So the only line that's going to be tangent would be this line down here, and you can call it any two of the three letters. So you can call it line AB, like they said in the beginning, or you could call it line DB, because that's still 2 points. You could call it line AB or AD also. And any of those are talking about this same line. So any 2 points out of those three that are on the line, and then you have to have arrows on there to show that it's a line and not a segment. Next section, it tells you that this is a tangent line, and that means that right here is a right angle. So that means you can use Pythagorean theorem. R squared and 40 squared are the two legs, and 50 squared, there's your hypotenuse, the one that's across from the right angle. So working this out, 40 squared is 1600, 50 squared is 2500. Subtract from both sides to be fair. That's going to be 900, and then if you square root that, you find out the R is 30. Next one, where the J is at, it has to be a right angle because this is a tangent line hitting the radius. So R squared and 15 squared go together, and the 17 squared is your hypotenuse, goes on the other side. So R squared stays R squared, 15 squared is 225, 17 squared is 289. Then you need to subtract the 225 to move it across. So 289 minus 225, that gives you 64. Last step, square root it. Your radius is 8. Last one, your right angle will be right here where the J is at. So R squared, 8 squared, those are going to be your two legs. 10 squared, there's your hypotenuse across from the right angle. Work the problem out. R squared is 36. Last step, square root it. You find out your radius on number 8 is going to be 6. Last section on this is the jack-in-the-box problems. So right here, remember that if it looks like that, like a cone shape, you know these have to be equal. Done. Over here, these are also equal. So on this one, you got to do a little bit of algebra. Subtract 7 on both sides. you get 6. Same thing here, a little bit of algebra. These are equal to each other. Divide both sides by 2. You found x. And then number 12, these are also equal to each other. Divide both sides by 3. You find out your answer is 2. On the back side, if a line is tangent to a circle, then it is blank to the radius drawn at the point of tangency. Perpendicular. Second one, in a plane, if a line is perpendicular to a radius of a circle and its endpoint on the circle, then the line is blank to the circle tangent. Number 3, if two segments from the same point outside a circle are tangent to the circle, then they are congruent. And you could use the symbol for that, which is the equal sign with a little squiggle on top. That would also count. Number 4, it tells you that this is a tangent line. So if you're looking for the measure of angle CDE, it's right here. It has to be 90 degrees. Over here, it says EF is perpendicular to CD. That's why there's a square right there. EF, it's asking is EF tangent to circle C? Well, no, because this point is not on the circle. So, no. And then point D is not on the circle. This one tells you that these are tangent. That means we do have right angles on all 3 of these examples. Next section, number 6. We have right angles on all of these because it tells you that PQ is a tangent on all 3 examples. So over here, the X and the 80 are both your legs, and the 100, that's your hypotenuse. So x squared plus, then 80 squared is 6,400, and 100 squared is 10,000. So then you subtract 6,400 from both sides. X squared equals 3,600, and when you square root both sides, you find out the x on this one is 60. Next problem, same process, x squared, 10 squared, 26 squared, 10 squared is 100, 26 squared is 676. Subtract 100 on both sides, you get 576. And then when you square root 576, you get 24. Next problem, x squared, 9 squared, 15 squared. We still have the hypotenuse being the longest side. X and the 9 are the 2 legs. 15 squared is 225. Subtract 81. You get 144. Square root both sides. And you find the x is 12. Next problems are the jack-in-the-box problems. Remember, these are equal to each other. So 3x equals 24. Divide both sides by 3. You find your x is 8. Next problem, make 2x plus 3 equal to 25. Subtract 3 from both sides, you have 22. Divide by 2 on both sides, x is 11. Number 11, 4x plus 9 equals the x plus 12. Subtract x to move it to the left. Subtract 9 to move it to the right. Divide both sides by 3, and you find your x is 1. And then this last problem, the r and the 4 would be your legs. The r and 2 together is your hypotenuse. 4 squared is 16. And then don't forget right here, r plus 2 squared means r plus 2 times another r plus 2. So you need to distribute the r into both of these terms. and then distribute the 2 into both of these terms, and then you have to combine like terms. Nice thing is r squareds will cancel for you. You need to subtract 4 to move it across. Last step, divide by 4 on both sides. And you found your radius is 3 feet. The question on number 12 was asking if the radius is 4, is it a tangent? So if it was 4, you would go 4 squared plus 4 squared equals 4 plus 2 squared, because you'd be replacing that r and that r with 4's. And then 4 and 2 is 6. That does not work out. So on number 12, no, AB would not be a tangent. For number 13, it says find the radius, which is what we did. So that's the answer for number 13.